Hello everyone, I'm Keith Epperson. I currently attend University of North Texas. I'm pursuing 2 degrees, ATPI degree and a Bachelor of Science in Electrical Engineering. I currently hold an electronics degree, Associate's Electronics degree, and also have 20 years experience in the electrical and electronics trade, and also have a journeyman electrical license. I hope everybody enjoys this presentation of sparks and arcs, how to be safe around electricity. I must warn you though, there's some of these images are a little graphic in nature. But what we're going to learn today is safety around arc flash and what arc flash is and some of the National Fire Protection Association rules that pertain to it. The nature of electrical arcs. It has very high temperature. It's up to 35,000 degrees. It's 4 times the surface of the sun. All known materials will vaporize at that temperature, and it will also ionize the air. There's a photo of an arc flash. My video. We've got a short video of it. Get to it.
The risks of an arc flash are hard to comprehend on paper, but when you see what happened in front of you, those risks are undeniable.
What is an arc flash? An arc flash is a hazardous release of energy that's caused when electricity that should be inside the wire gets outside the wire, is a little bit of a simple way to put it, but now you have ionized air and plasma, and along with that, a shock wave or pressure wave, and any shrapnel that pressure wave might be pushing, and molten metal at 1900 degrees Fahrenheit or hotter, all of that coming at you at once.
Westex, a flame-resistant and arc flash-rated fabric manufacturer, recently held a demonstration day in Toronto. Westex's technical director, Scott Margolin, says anyone who works on or near energized electrical parts should be aware of arc flash.
These things project. The energy comes out of the arc gap, particularly in industrial gear as opposed to in a pole open-air spherical arc. So the plasma is going to come out. The molten metal is going to go 7, 8, 9 meters in all directions, 180 degrees around the equipment that's faulted. The pressure wave is going to come out as well. So the hazard is not just to somebody within a half a meter or a meter of the thing. It's to anybody within 4 or 5 or 6 meters, depending upon the energy level and what just blew up.
Understanding how to protect yourself begins with understanding how arc flashes are measured. An arc rating is the amount of calories that a fabric can block with a 50% likelihood of sustaining a second-degree burn through it.
So what an arc rating does is using the apparatus behind us, but with panels instead of mannequins, so that they're flat fabric panels. 3 panels in each arc, 7 arcs gives you 21 data points, and the computer then measures the 50% probability. In the case of this fabric, it's 8.7 calories, and that becomes your arc rating.
Knowing the arc flash hazard of a piece of equipment allows for better protection.
Simply wearing flame-resistant clothing is no longer enough. If you know the arc flash hazard is, let's say, 9 calories, then an 8-calorie shirt isn't sufficient. 8 is less than 9. You need to layer up. If you know the arc is 6 calories, an 8-calorie shirt is just fine. So this idea of matching the hazard to the protection is relatively new in arc flash.
Arc-rated clothing achieves 2 things.
Number 1 is for the fabric not to ignite and continue to burn when the heat source is removed. The second thing that you want that fabric to do is once you've gotten to the point where it doesn't ignite, now you'd like it to insulate you as well from whatever hazard you face, so that not only is your burn not made worse by ignition, but also you're not burned at all because it's insulating you against that hazard.
Scott warns people not to confuse arc-rated clothing with flame-resistant clothing.
All arc-rated clothing is flame-resistant. It has to be flame-resistant just to get in the test apparatus. But not all flame-resistant clothing has been arc-rated by the apparatus.
There are in the neighborhood of 30,000 arc flashes in the US and Canada combined on an annual basis. This results in 7,000 injuries to paid professional electricians. Scott says this is 1 every 15 minutes in a regular 40-hour work week. Of those 7,000 injuries, 2,000 of them will result in hospitalization, and 250 of them will result in death. In order to prevent this from happening, people need to be informed.
The arcs are going to happen. People make mistakes. Equipment ages. Things fail. Conductive dust causes a lot of these. But when the arcs happen, the consequences do not need to be fatal or catastrophic injury. That part is avoidable by simply not working hot if you don't have to, and if you're going to choose to, recognize and dress to the hazard in arc-rated flame-resistant clothing.
As you can see in that video, their clothes just almost blew completely off immediately. That was an interesting thing. Did you actually get to see? Oh yeah, a little technical difficulties. Alright, what causes an arc flash? It can be a spark discharge, which is accidental touching from humans or animals, dropping of tools, non-insulated, sparks from loose connections, and insulation failure, flash over across small gaps. The arc flash hazards, which is risk of burn from intense heat, which you could see from that video, is very intense. Sprayed molten metal, you could see that also from the video. Toxic gases, because all that gets vaporized, all the insulation, all the plastic, all the metal gets vaporized, and you actually will be breathing that stuff. And the hearing loss from the sound pressure wave, ultraviolet and infrared radiation, and risk of trauma from the blast pressure, which that really causes internal injuries. Arcing faults, release dangerous levels of radiant heat, capable of causing severe burns. Fatal burns can occur up to 5 feet from the arc, with serious burns up to 10 feet away, which that's a very interesting fact. Clothing is ignited several feet away. Molten metal. Arc sprays drops of molten metal. This explosion distributes the molten metal produced by the arc over a large area. The heating of the air, expansion, and the blast pressure waves. It's known to throw workers across the room, and it knocks them off the ladders. Can create massive internal injuries without even no signs of outside injuries. And they've documented these at 2,000 psi. No protection against arc flash. The personal protective equipment we discussed only protects against the burns, not actually from the blast itself. There's no, it's because the internal pressure could be enough to injure you without even the burns. The ultimate limit injury levels that can be safely worked. And this is a rotation meter. You can see the one on the left, that's what it's supposed to look like when it's brand new. And that's one that the worker, it blew up on him. There is the panel that he actually was testing the rotation of the motors, and that was his unprotected hand. This is some of the key requirements from NAFTA. All companies have to supply an arc flash hazard analysis. They have to have their electrical drawings up to date, and they have to do a short circuit analysis, and they have to check their breakers regularly for make sure there's not any issues. Like they usually do a heat scan, ultraviolet scan to make sure there's no hot spots, that kind of stuff. And this is how they calculate the calories. The calories amount of energy it takes to raise temperature of 1 gram of water to 1 degree Celsius. 1 calorie per centimeter square equals the amount if you hold your finger over a flame for 1 second. 1.2 calories per centimeter squared is a second-degree burn in 0.1 seconds if you was to put your hand on the oven door. And NAFTA has these different boundaries they require to do. This is the limited approach. It defines around exposed live parts that may not be crossed by unqualified persons unless accompanied by a qualified person. Maybe closer than the arc flash boundary. That picture just shows an example of the boundary. This is the restricted approach boundary. The boundary near exposed live parts that may be crossed by only a qualified person using appropriate shock and prevention techniques. Concerns the shock hazard. This is the prohibited approach. The shock protection boundary to be crossed only by qualified persons. You gotta use that basically as it's, you're working on a live wire. And what is a qualified person? It is one who has been trained, that knows the hazards of the electrical. And back when I was started, I worked with a bunch of old electricians. They would test the wires and wet their hands and actually touch it. That was common practice back then. Now that's not a good thing. And this is the actual label that would be on a breaker. It shows that flash hazard boundary and how far all the little boundaries we just went through. It should be on every piece of electrical equipment in factories and different areas. Why is fire retardant clothing required to work on energized electrical equipment? The intense energy and heat is an arc flash is capable of igniting combustible work clothing. Fire retardant garments are designed so that they will not continue to burn following arc exposure. Will flame retardant clothing protect the wearer from burn injury? No, because it only protects you again beyond second-degree burn. This shows an example. You can see he was wearing his shirt, but you can see he wasn't wearing a helmet. You can see where his shirt was. There's no burners, and above it, it's all burned. These are the examples of the different levels of protection. You can see as the level gets higher, it gets more heavier, more cumbersome. And category 0 is just basically a shirt, a cotton shirt, your gloves, and your flame retardant pants. In category 1, it gets more thicker. You got to add more layers until you get all the way down to 4, which is, if you've ever wore that, it's very uncomfortable and it's very, very hot. Flame retardant clothing this is a level 4. Does anybody see a problem with this picture?
Not wearing the protective boots, proper PPE.
They would just pose.
And slippers on or something.
Yeah, those are not electrically rated boots or shoes. Can they be washed at home? No, because they have to. It has chemicals on it. If you wash it, you can take that chemical off, and it will not be considered a flame retardant suit anymore. When should the flame retardant garment be changed or retired? When it's tore, worn, it starts seeing holes in it, it needs to be changed. And whenever you got oil on it as well. And this is usually what most companies have as an electrical work permit. This is what most standard places have. And I have an example of it. And that is the presentation. Does anybody have any questions?
What kind of voltage were these ordinarily,
The ones that were in the video,
yeah,
they were 480.
480?
The higher the voltage, the more likely, the more massive the arc flash will be. Like 120, it doesn't have as much energy there to cause a big arc flash. But, the higher the voltage, the bigger the arc flash.
We have several motors on 480.
Yeah, that's, when you see them, you don't realize that they can happen. Any more questions?
So the shoes, what kind of shoes would you recommend for
They sell.
having those?
They sell the ones like the work boots that have the insulated soles, so that way you're not grounded to the ground. Just the regular steel toes are not considered electrical safe. They have to have special toes in them because they can be conductive.
And I noticed that it said they had to have different gloves. too.
Yes, their work their gloves. They have a rubber.
Do they come with the
Yeah, they have a
outfit?
No, well, usually the company will supply it. They have a rubber insert, and then they have the leather that protects the gloves, the rubber itself. Because if you pinch it, that can also cause people been shot through the glove because they have a little pinhole. So you're supposed to test those before every time you work on any equipment. You take them out, blow on them, and then roll them up, and then put them up to your face to see if you feel any air blowing past it. And they're supposed to also be checked every 6 months. They're supposed to be sent out to be checked. Usually they just send you a new pair. Usually they don't, because they get cracks, dry rot, that kind of stuff.
Well, and you also talked about boundaries in the presentation. Do you set up the boundaries whenever you start working, or is it something that they're just supposed to know?
There's usually when you open a panel, you're supposed to put, just like that one picture where they're supposed to barricade it back that far. That's how. But it all depends on what size panel it is. The higher the voltage and current, the further back that has to move. So the electricians usually will barricade that off, and anybody's not allowed in there unless they are accompanied by a qualified person.
Whenever you say companies do like a heat test, what type of heat test do they come out and do? Like thermal imaging?
Thermal imaging, where they have the thermal imaging camera and they can take a picture of it and it shows the different colors. It could be hot, they can see where those bolts are not tightened good, or you may have a faulty where the knives slide into the breaker itself. Could be the springs could be going out. That's that kind of stuff.
And that helps prevent the
Yes.
future of
Yes.
arc flashes.
That is part of their studies that they're supposed to do. All right, thank y'all for attending my presentation.